Aloha, Richard Halverson here. This is ICS211, and today I'm going to in this video I'm going to just cover sections 14.8, the Q interface, and section 14.10, the Deques interface. And the two labs that go along with these two sections will be in a later video. So let me share my screen. All right. The Q interface, you probably all know this already. Q interface is defined within the Java collections framework. It defines a collection of ordered elements that support element insertion at the tail and element retrieval at the head. Okay, so does it tell us what we need to? Yeah, this stuff too. This stuff's important. You gotta stick that here at the top, and you gotta stick this in there too. Both of them, both linked lists. A queue is a linked list, and so is a deck. Is a deck a linked list? Let's see. Deck. Yeah, it is. Deck's a linked list. And so this goes on sort of on top of that. Anyway, let's go back to queues first. So it's pretty simple as you'd expect. Oh, you gotta make sure you do all these. Do we do them here? So there's the important methods that come along with a queue is add and remove. And add, of course, adds to the tail of the queue, and remove removes from the head of the queue. And so this is how you define a new queue. It's a linked list. And so here we're adding to the queue, and then this removes them. And it's going to remove in the same order that it was added. The first one in is the first one out. So this is a summary of common queue methods. You can add and remove, and that actually changes the size of the queue. Add puts one in there, and remove actually takes it out, returns it to you. Poll will just remove and return the element at the head of the queue. If the queue is not empty, otherwise it'll return null. With these, like for example, remove, if you try to remove and it's not there, it's going to throw an exception. Poll will not throw an exception. Element returns but does not remove the element at the head of the list. Throws an exception if it's empty. Peek does the same thing, except for it does not throw an exception. It just returns null. Oh, goody, a challenge activity. Let's see. Well, this one is pretty easy. Let's see. We're just going to define a queue called colors, insert 3 of them in there, and then remove one, and just display it out. Okay. Let's see. I'll do the second one. We're going to add these 4 names to the queue, and then we're going to print poll, and then we're going to print peek, and then we're going to print element, and then we're going to, it's not going to do anything. It's not going to change the output. So poll polls the head of the queue. Polls the, does it, I get an, okay, it doesn't tell me what to do if I get an exception, so I assume I'm not going to get one. This one's going to poll the top, and it's going to return ed, but it doesn't take it away. This is going to peek. It's going to say ed, but it's not going to do this poll. Let me see this. Poll removes and returns. Okay, poll actually does remove. So this one, the next one is going to be Ava, and that's just a peek. Just a peek, does not remove. And after that, it's going to print element. What's element? Returns but does not remove. Throws an exception. Returns but does not remove. Okay, so it's just going to do Ava again. That's it. Did I put 2? Did I put 2 returns here? 1, 2? Well, anyway, you can fix that and do it right. That's weird. I wonder if there's 2 returns in there. That must be it. But it sure is misleading. Anyway, all right, let's go to okay, so I'm gonna do the lab in another video. I'm probably gonna make that video right after I do this video, okay? But let's go to Deck. The idea is that you should try to do the labs yourself, and then you're learning the most. You're stimulating your mind the most. But if you're stuck, you just can't do it, then you can watch the video and you'll be able to almost do the whole thing. It takes a while to watch the video, and lots of times you should just be able to look at it and figure it out in less time than it takes you to watch the video. But all right, so let's look at the Deck interface. And Deck, pronounced Deck, interface is defined within the Java collections framework as a collection of ordered elements that support element and insertion at both ends. Okay, so a queue is you insert it at the tail and take it out at the end, take it out of the front. A stack is you put it in at the front and you take it out at the front. Okay, you don't touch the back end of it. A deck is like both of them put together, and you can do whichever you want. So you can insert in the back, take out of the back, insert in the front, take out of the front. It's the most versatile. So here we have a deck called that. And first we're going to print this out. And then we're going to add Tokyo in the beginning. And then we're going to add Osaka in the beginning. And then we're going to add Nara, sorry, I don't know how to pronounce it, in the beginning. And then we're going to remove the first one, remove the first one, remove the first one. So that means it's acting like a stack. Tokyo, Osaka, Nara, Nara, Osaka, Tokyo. All right, so that's a deck. That is a deck using a deck like a stack is what that is. So here are the common deck methods. As you might guess, it's all the ones that we've seen, except for it does both ends. You either throw an exception. If it's not there, you either throw an exception or you return null, depending on which one you want to do. So adds at the beginning, at the head of the queue. This adds at the tail of the queue, of the deck, at the end of the deck, the tail end of the deck. This removes the first one and throws an exception if it's empty. This removes the last one, throws an exception if it's empty. This grabs out the first one, and if it's empty, it just returns null. This grabs out the tail end, grabs from the tail. It returns null if it's empty. This gets the first one, but doesn't remove it. Throws an exception if it's empty. Gets the last one, doesn't remove it, throws an exception if it's empty. Just returns, returns the first one, returns null if it's empty, returns the last one, null if it's empty. Doesn't remove it. Okay, so let's look at this last challenge here. We're gonna create a deck here called invites, and we're gonna add Bill at the beginning, and keep the beginning, add Liz at the beginning, and remove Liz. This is wrong. No, never mind. So remove Liz, and then we're gonna remove Keith, because Liz was removed here, and then this is gonna remove Keith. This actually does remove. Okay, so that's how this works. That's how the first one was. So I'm gonna start this up, and I'm gonna do the third one. And let's see, so we're gonna put 95 in there, and then we're gonna put I'm gonna make it right here. We're gonna put 95 in the beginning, and then we're gonna put 1 in the beginning in first, and then we're gonna add 99 at the tail end, and then we're gonna add 77 at the tail end. Okay, I think that's right. First there's 95, and then 1 goes before that because it's first, and then we add 99 at the end, add 77 at the end. And now we're going to print out stuff, and we're going to print out the last one. Just pull, take it away. Removes, pull, removes. Okay. So we're going to print out the last one, and then we're going to print out the first one, and then we're going to print out the first one, and then we're going to print out the last one. Okay, so let me just go like this. Pull last. First, we're going to print out 77. So that's gone. And then we're going to print out the first one, which is 1. So this is gone. And then we're going to print out the first one again, which is, looks like it's 95 now. And then we're going to print out, so now this is gone. And then we're going to print out 99, which is the last one. So I'm going to back this up here, and it's print line. So there should just be 1 after that. And let's check and see if this is correct. Yes, it is. All right, very good. So that's queues, stacks, Deques. Thanks for watching.